In the skies, there are few milestones as significant as the introduction of the Airbus A320, a commercial aircraft that not only changed aviation history, but fundamentally transformed how pilots interact with their planes. Today, I'm diving into the aircraft that brought fly-by-wire technology to the forefront of aviation, revolutionizing cockpit control systems. First flying in 1987, the A320 was Airbus's bold entry into the world of commercial air travel. At the time, aircraft technology was steadily advancing, but the A320 would go on to become a game-changer, particularly because of one groundbreaking innovation. Prior to the A320, aircraft were operated through mechanical linkages, heavy cables and pulleys that connected the pilot's controls to the aircraft's control surfaces. While effective, this system had its limitations. The A320, however, would be the first commercial airliner to replace these mechanical systems with something entirely new: fly-by-wire technology. At its core, fly-by-wire is about replacing the traditional mechanical controls with electrical signals. Instead of physical cables, sensors in the cockpit send commands to the aircraft's flight control computers. These computers, in turn, send electronic signals to the aircraft's control surfaces, allowing for a much more responsive, precise, and efficient flight control system. With fly-by-wire, pilots no longer need to wrestle with heavy mechanical linkages. Instead, they interact with a set of electronic flight control systems, including the aircraft's flight control unit, FCU, and the side stick, which offers more intuitive handling, especially at high speeds and in turbulent conditions. This was a radical departure from the traditional yoke and throttle setup, and the A320's side stick control became one of the most iconic features of the aircraft. It provided pilots with much more freedom of movement and less physical strain during long flights. Fly-by-wire technology offers several distinct advantages. For one, it greatly enhances the aerodynamic efficiency of the aircraft. With advanced computers interpreting the pilot's input, the system can make split-second adjustments to the flight surfaces, maximizing the aircraft's performance and fuel efficiency. Additionally, the fly-by-wire system allows for automatic flight envelope protection, meaning the aircraft's control systems are designed to prevent the pilot from making unsafe inputs that could lead to a stall or excessive G-forces. The system effectively keeps the plane safe by adjusting commands in real time. In essence, the A320 was one of the first airliners to fly smarter, with a system that not only responded more efficiently to pilot inputs, but also actively prevented certain dangerous flight conditions. For pilots, this change meant a dramatic shift in how they flew. The digital fly-by-wire systems gave them more control over the aircraft with fewer physical limitations. This also led to a reduction in pilot workload, especially in critical situations like landings or bad weather conditions. Airlines quickly saw the benefits of the A320. With its more efficient handling, lower fuel consumption, and reduced maintenance requirements, the aircraft became one of the most cost-effective commercial airliners in history. It wasn't just a technological breakthrough, it was a business one. Decades later, the legacy of the A320's fly-by-wire technology still influences modern aviation. Today's A320 Neo variants build upon that original vision, offering even greater fuel efficiency, better passenger comfort, and more advanced technology. Moreover, the success of the A320's fly-by-wire system paved the way for other aircraft manufacturers, including Boeing, to develop their own versions of electronic flight control systems. In many ways, the A320 set the stage for the future of flight, where computers and pilots work together in perfect harmony. The Airbus A320 was more than just the first commercial aircraft to feature fly-by-wire technology. It was a true leap into the future of aviation. Its innovations continue to shape the skies we fly in today, proving that sometimes it's the smallest changes that make the biggest difference.